Hello, welcome to APES Chapter 18, lecture video number 3. Let's begin by talking about precipitation. Well, rainfall on the planet. Well, as the Earth gets warmer, which is what's happening, certain regions, I mentioned this in the last lecture, are getting more rainfall than normal. What regions are those? Equatorial, tropical areas. And you'll see here that this dark blue is a larger percentage. Blue means more precipitation's happening. Okay. Areas are getting more precipitation. Some areas, for example, are getting even drier, like the deserts of the world are even getting drier. So it impacts different parts of the world differently. Now, the new norm, they're calling it extreme weather, and it sounds interesting. So, how can we say extreme weather is becoming the new normal? What we are using, what they've been using is data that comes from the insurance companies that have to insure these disasters after they take place. So they have actual numbers on what things cost and how much damage actually takes place. So we've been using insurance data for a long time. And this insurance data is showing us that these extreme weather events are not as uncommon as they used to be. They're becoming much more common. What is happening? All right. Well, I mentioned earlier that the area of the world that is the most impacted by climate change are Arctic regions. Okay. Here's what's happening. All right. Here's what's happening. There's this jet polar stream in the northern hemisphere. All right. Jet stream of air that flies across the United States like this. As it's getting warmer, the jet stream is actually looping more. It's not it's not going as like it used to from west to east the way it used to. It is now creating a looping pattern due to this changing climate that we are experiencing. Now, this looping pattern, why is it a problem? Well, this looping pattern causes weather occurrences like persistent hot weather or persistent cold weather to get stuck in an area and not move and pass through the area like it normally would. So it's blocking the eastern movement of weather patterns. Weather is getting stuck or held in place, creating prolonged bouts of these extreme weather occurrences. So the extreme weather occurrences are happening and they're getting stuck in specific places longer than normal, longer than expected. This is one of the problems with the climate changing. Melting ice. So, what is going on here? Well, ice sheets are melting, and this water is basically making its way into the ocean. It's causing the ocean to rise. The ocean is not only rising because of this additional ice that is now making its way into the water, this melted ice that's making its way into the water. Thermal expansion. Remember, I mentioned it in an earlier lecture. As the gases inside of the ocean already get warmer, they expand, and the ocean is actually taking more space, takes more volume, which means it's getting bigger, so to speak. And getting bigger means oceans are rising. So this is showing you what these areas looked like almost 100 years apart. Areas are covered with ice, and they are no longer like that. I have been personally to Alaska with my family, and I recall specifically looking at different glaciers in different areas where there was ice in Alaska, and they built an area for you to look out and see it, and the lookout area is nowhere near the glacier anymore because it has receded so far. So the term is glacial retreat. You may see that term on an AP test. Glacial retreat doesn't mean the glacier is moving and leaving. It means that it is melting away and it is retreating from that location. So glacial retreat is a common term. As it melts, it's retreating, and this is what it looks like nowadays. You don't have as much ice on the ground in general. Okay, so I explained the albedo effect in an earlier lecture, but let's do it again because this is coming up on your AP test for sure. All right. So it's real simple. As snow and ice melt, snow and ice are that white color, and they're very reflective. As they melt, they affect the ability of that area to reflect light. So ice has a very high albedo, a high ability to reflect light. Lack of ice, ground, and water has a low albedo. So what's happening? Ice melts. Darker, less reflective areas and water, land are exposed. What do they do? Those darker areas, they absorb more radiation, and therefore they get warmer than they would have before if they were reflecting it. So when they reflect it, they don't absorb it. When they reflect it, it goes away. It's dealt with somewhere else. They're not absorbing that energy. All right. Here's what else is happening. There's Methane stored in some of the gas. Methane is stored in this frozen ice. So there's this thing called methane hydrate, methane which is found in frozen ice areas. As more of these glaciers and these ice sheets melt, we're going to release more methane, which is a terrible greenhouse gas. And now the earth will get warmer, causing more ice to melt, releasing more methane. So these are what's called positive feedback loops, which are bad for the environment. The albedo effect, positive feedback loop. Ice gets warmer, ice melts. Then the area gets warmer, more ice melts. Then the area gets warmer, more ice melts. The area gets warmer, more. It's a positive feedback loop. These are positive feedback loops that throw the nature out of balance. So rising sea levels, all right? And there's thermal expansion mentioned right there, all right? General increase in the volume of material as temperature increases. That's what's happening in the ocean. It's not just extra water being dumped in. They're expanding because they're getting heated over and over again. Worldwide, sea levels have risen about 24 centimeters in the last 135 years. That's a lot if you really think about it. Most people don't realize how much that is. What happens with rising sea levels? You need to know all the impacts of rising sea levels. Common one, you're going to have beaches erode. Most people are going to be like, well, what's a big deal? I don't live at the beach. But if you do live at the beach, it would be terrible. If we said, your backyard was going to erode away, people would have issues. So some people's backyards are going to erode. They live near the beach. They live in coastal communities. Coastal flooding, I already mentioned to you earlier, saltwater intrusion and freshwater aquifers. Miami Beach has water coming up from the ground, salt water coming up from the ground. You're going to have major areas with storm surges because of this rising temperatures, rising water. You're going to have major problems with storm surges in coastal communities. It really impacts coastal communities. The majority of rising sea level does. So not all of us are gonna ever live in a coastal area, but there are a lot of people there. In the United States, based off of the insurance data, storms are getting crazier and crazier and crazier. We had Superstorm Sandy that crushed the East Coast. It was extremely expensive, extremely expensive. So storms are getting bigger, more powerful as a result of the warmer climate. You got to think warmer temperatures will cause more water to evaporate. That warm water that is evaporated, now it's steam basically in the form of steam or gaseous water, and that water is containing energy. And the more evaporation you have, the more energy you have, and these storms are getting energy boosts from this warm water. This was in an oceans chapter. We talked about the ocean getting more acidic. What is causing it? Well, carbon dioxide forms carbonic acid like carbonation in the ocean, and the ocean is getting more acidic. So the pH is decreasing as a result of this carbon dioxide. A lot of it is being absorbed in the ocean. This was in our previous chapter. Less carbonate available, shelled organisms, really bad environment. Anything with an exoskeleton or a shell is going to struggle as the pH drops. They won't be able to produce shells as quickly as they erode due to the lower pH of the water. Here's what else is happening. Here's a personal experience of mine. I've been surfing in San Diego since I was a child. I'm in my 40s, so let's say I've been in the water for 40 years. A couple years ago, I noticed a weird-looking type of invertebrate, type of jellyfish in the jellyfish family in the water. It was very strange. I'd never seen this before. And I've traveled the world. I've been to other parts of the world where jellyfish are very dangerous, like in Australia, where they can kill you. Little small box jellyfish can kill you. So I saw these weird-looking jellyfish in the water in La Jolla one day, and I was curious. I'm like, what's going on? I knew they weren't dangerous because people were touching them in the water. It's hard not to touch them. They were all over the place. So if you were in the water, they were probably touching you. I got out of the water. I started talking to a gentleman. I believe he worked at Scripps Oceanography Institute. And what he told me is that as climate has changed, the areas have gotten warmer, the equatorial areas have gotten warmer, and the organisms are migrating. So he said these jellyfish-like organisms were migrating from areas where the water was getting warmer than normal, and they were coming more north to get away from that heat. So we were finding life in our water that I had never seen in 40 years. I'd never seen jellyfish like that before. They were blue and they were odd, and I have never seen anything like that in our water before. So Things and organisms are moving as a result of necessity to areas that they can survive in that aren't quite as warm. Plants, because the climate is changing, they're leafing. They think spring is happening sooner in some cases. All right. Birds, migrations, everything is shifting. Organisms are not only going to higher latitudes away from the equator, they're also going to higher altitudes also. So climate change is affecting ecosystems. Organisms are going to higher altitudes, okay, because it gets cooler, and they're going to higher latitudes because it's cooler. So the migrations of organisms is changing as a result of climate change. How is it affecting society? How's climate change affecting us? Well, extra CO2 is actually good for plants, and you might get more plant growth as a result of this extra CO2. But extra CO2, the warming factor, might lead to, we just talked about organisms migrating, invasive species showing up that don't belong there, fires that you didn't expect to burn much worse than normal, disease outbreak. As climate gets warmer, as climate change occurs and it gets warmer, there will be more insects such as mosquitoes. Okay. Mosquitoes like warmer, damp, tropical type of climates. Well, as the tropical areas expand because of this warming of the earth, you're going to have an increase in the number of mosquitoes. Increasing the number of mosquitoes means increasing amount of certain diseases that are transferred by mosquitoes. Okay, so more insects means more potential disease outbreak, like malaria, which is transferred by mosquitoes. What else is a warmer climate, excuse me, going to expose us to? Well, more heat waves, simple. Um, More sun means more brown or photochemical smog, which means respiratory potential. More mosquitoes, I just said, more malaria in areas you normally wouldn't have it. Flooding, sanitation issues, that's a major problem. Water in areas you don't want it, and major storm surges, which could lead to drowning and deaths as a result of that. Now, impacts vary by region. What this is showing you is what's happening. This picture here saddens me. If you see a pictures of polar bears today on our planet, you will notice that polar bears on our planet right now, they are struggling. What is happening? All this melting ice means there's less surfaces for these polar bears to cruise around on and look for food. So there's less land and less frozen landscape, less ice for them to traverse looking for the things that they like to eat, like sea lions and things of that sort. And the fish or whatever it is these bears will get their hands on and they'll eat. The problem that they're having is if you see them, they are emaciated, skinny bears, bones, like bags of bones. So the climate change is really impacting organisms and that rely on these ice sheets to look for their food. The polar bears are just getting crushed big time on our planet. It's very sad to see what's happening to the polar bears. This is a list in your book of predicted impacts due to climate change. And this is the US. And I've gone over a lot of these things: droughts, flooding, wildfire, extreme weather, sea levels rising, storm surges, beach erosion, real estate destruction, insects, health problems, disease, pollution, droughts, fire, ocean acidification. There's a lot of things that are connected to climate change. All right. And we will stop there.